Anyway, here I have an Addmaths paper from May-June 2023. So this was just a few months ago. So the answer key for this has not been released. We don't know what the answers for this paper is, but I'm gonna solve it anyway because I'm built like that. So they give you all the equations. A lot of people tell you memorize this, but they actually give it to you at the front. So yeah, you can forget about all this stuff here. First question, solve the equation where this over 7 equals 1. So this is actually so simple. They should actually make this 1 mark, because first you want to isolate, yes, the modulus. So you bring the 7 across, right? So divided by 7 is 1. That means you bring 7 over, it's times, right? So the modulus 4x minus 5 equals 7. So now that you have this, a lot of people would square both sides, but it actually makes it very complicated. So instead, we're gonna split this into 2 separate parts like this. So 4x minus 5, I'm doing this on mouse, equals 7, and we're going to do a negative version of this on the other side. So that means negative 4x plus 5 equals 7. And now, you just got to solve this. It's so simple. Let's do this side first. Right? You bring the 5 over. You got 7 plus 5, that's 12. Then 4x equals 12, right? So that means a single x would be 12 over 4, which is 3. That's the first one. Now for the second part here. We bring the 5 over, so that's 7 minus 5, that's 2. So that means negative 4x equals 2. So x is 2 over negative 4, or negative half. Damn, just like that. That's the to this next question here. It says the diagram shows this graph. So that means this is this v over here. And now they want you to draw another graph on it to solve this. So they actually want you to draw this thing out, which, you know, if you do normal maths, I'm sure you know how to do this. So I'm not actually going to count this because it's so boring. It's probably going to look like this. And this thing is a modulus. I'm sure you know what that is. If you don't, what are you doing in Addmaths? It just means that values cannot go under this x-axis. So it says to solve by looking at this. But we're not actually going to do that, because that's inconsistent and extremely risky. So what I'm going to do is solve this normally. So you got 3x plus 9 modulus is less than or equal to x minus 5 modulus. So we got to remove the modulus. I'm sure you know how. You got to square the sides. So you got 3x plus 9. You square the entire thing like this. Okay. So now you just gotta expand it. So 3x times 3x, you got 9x. 3x times 9 would be 18. Why am I counting? 27. Yes, 27. Then another 27, you got plus 54x. Oh, that's a square. And then plus 9 times 9, 81. Yes, that's one side. Then the other side, x times x, yeah, that's x squared. Minus 5x minus this minus 10x, and then finally like positive 25. So yeah, you have these 2 equations here. Bring everything to one side so that it would equal 0, right? You got something x squared plus something x plus a normal number, and then you solve it with quadratic formula. I'm sure you know the song. So moving on. Alright, so this question here, they want, oh, you can't use a calculator. Who cares? I don't use a calculator for any of these questions. It's too easy, honestly. Alright, write this expression here in the form of this. So you just gotta turn this into this. So when there's no calculator, it actually doesn't mean like they wanna just make your life miserable. It actually means a few things here. It means that there's no formula at work here. You just gotta think, and just by looking at this, I can tell a few things. Alright, it takes quite a sharp eye like mine, you know what I'm saying. But this numerator here, I can see it. I can break this down. Alright, so we got this square root 98 x 12, right? But 98 is 281. Yeah, this 98 here is broken down into 7 square times 2, because that makes 98, right? Then times x 12. right? Yeah, so this does get converted to this, and then because they are now squared, they cancel each other out. So square root of 7 square is just 7. Square root 2 we don't know, so we're gonna leave it at square root 2. And then square root x12 is x6. I hope what I'm doing is correct, I'm just assuming here. Then over 3 plus square root 2. Yeah, I converted the numerator like this. Okay, so now it looks more digestible, right? Easy to understand. So I'm going to teach you a technique here where you multiply the whole thing by 1. What does that mean? Well, actually, it's not 1. You're going to multiply this, but a negative version like this. 3 minus 2x square root 2. 3 minus square root 2. This is 1, right? Because it's the same thing over itself, so this makes 1. So what I'm doing here is just expanding it to make it more understandable. I'm just going to assume this works. So I've actually calculated this on another piece of paper because I could not be bothered writing it all down with a pen. But if you multiply them correctly, which shouldn't be too hard, you should get negative 14 x6, this one term here, minus 21 x6 square root 2, and like this. Now a lot of people get it mixed up, a lot of my friends, especially those idiots, they think these are 3 terms, but actually these 2 terms here is one thing. So there's actually only 2 things on the top. Then it should just be over 7, because when you multiply this with this, it gives 7. Now let's ponder for a bit. It's important to look a bit. Yes, okay, I can tell. So if you look at the top here, I see a common thing between these 2, and that both of them have a negative 7x to the power of 6. Yes, alright, I can pull that out. So negative 7x to the power of 6, I can take it out of the bracket. So what I'm left with is 2 minus 3 square root 2. Correct? Yeah, I'm correct. Okay, this over 7. And now there's a 7. There's a 7. I cross them out like this. And what I'm left with is an x6. 2 minus 3 square root 2. Would you look at that? Would you look at that? That is exactly what... Okay, I did not arrange this correctly. Okay, it's technically like this. It's negative 3 square root 2 plus 2 with the negative x6 at the back. Yes, this is this. I have done it. Oh, we'll never know if it's correct till the answer key comes out, but I'm gonna assume it is because I'm a smartass. Next question. Differentiate this. Well, looking at the marks, pretty simple. When you differentiate anything that's alone, very simple. You just put it 1 over x3 plus 3x squared. You just put 1 over it. However, there's one more step. Then you multiply the whole thing with the differentiation of inside. So I'm not sure if you know what that is, but when you dy dx, you bring the power down and you minus the power by 1. So x3 would become x, would become 3x. Then it was cubed, but now it's going to become squared like this. Squared. Plus 3x squared, right? The 2, I'm going to bring it down to multiply the 3. So 3 times 2 is 6, yeah, very obvious. And then 2, you minus the power by 1. So instead of it being cubed, it's just x to the power of 1, which is x. And that's it. You can put this on top if you want to make it simpler, but I'm too lazy. There's a 2-hour time limit on these papers, so I'm gonna leave it like that. Alright, next question. This one. Okay. dy dx. No, this is integrate. Integrate is the opposite of dy dx. dy dxing is bringing that power down, right? But now you're basically doing it the other way around. But you can't do it for a fraction. This is actually pretty simple. You just gotta convert this into a more integratable form. So this part, I can break it down. Can I break this down? Yeah, I can break this down. This can be separated into 3x plus 3 plus 2 over 3 x, yeah. When you add these two together, you get this. So breaking it down into this makes it simpler, but we're not done yet. We need to separate the normal fractions away, because we can't differentiate, or we shouldn't differentiate, something that doesn't have an x to it. So I'm going to take it out, take the 1 over 3 away from the 1 over x plus 3. Right, because these two added together makes this. I only want to integrate this part here, and same with this side. 2 over 3, remove it. I only want to integrate the 1 over x. Now, does this look familiar to you? 1 over something. If differentiating alone gives 1 over something, then integrating, which is the opposite, should convert this into ln. So that means this is ln x plus 3, and this is ln x. It's very obvious. Now this part that's outside is untouched, you just add it back on. So 2 over 3, 1 over 3 like this, and now you just gotta put them back together, so 2 plus. And that's it. I'm not gonna spend time at them, the examiner knows. Next question. Show that the polynomial, that's just a very fancy word for a big fat equation that has a cube in it. So show that when x is -4, the root of the equation is 0. Very simple. You just put -4 into the x and it should give 0. You don't even have to show it, like just literally put it in, like 2, -4, 3 plus 11, -4. I'm not gonna write it, I'll just put -4 in there. You'll get 0, 3 marks. Now factorize this and show that this has no other real roots. Oh, okay. So this is very tricky. When it says that there's no other real roots, that means it's implying that this is the only thing, this x equals -4 is the only thing that can divide this, alright, or it's the only root. So when x is -4, it actually means x plus 4. So it's saying that this is the only root that can divide 2x3 plus 11x2 plus 22x plus 40. It's saying that this is it. I just need to show that this is true. And it's actually very simple. If I divide this whole thing with this, I will get some kind of number that cannot be factorized. That means it can't be a root, and this is the only thing. So, man, do I really want to do this? Okay, fine. 2x3. Okay, how do I make x into 2x3? I times it with 2x squared. So this is this, you get 2x3, and then this times this, you get plus 8x squared. This is just normal division. It looks complicated. You minus, this is 0. 11 minus 8 is 3x squared. Now you bring down the plus 22x. Then you continue. X plus 4. How do I make x 3x? I times it with positive 3x. That will give me 3x squared. Then 3x times 4 will be plus 12x. Minus, this is 0. 32 minus 10, that's positive 10x. Then you bring down to 40 like this. And now, so simple. You just multiply it by 10. Right? 10 times x is 10x. 10 times 4, that's 40. And when you minus 0, it's perfect. Now we got this thing here, and this thing, I don't even gotta tell you, you can't factorize it. That means that this x plus 4 is the only root. Just show it like this. Next question. A gardening group has 20 members. A committee of 6 members is to be selected. Anwar and Bo belong to the gardening group, and at most one of them can be in the committee. How many different committees are possible? So you gotta ask yourself, is this combination or permutation? I'm guessing combination. So there's 20 people. Okay, 20 people. Oh, these kind of questions, by the way, how they mark, how the examiners mark, I would know because I'm an examiner. They don't care about the working. They just want you to get the answer. So I recommend to just take your time, just write it all out, because it doesn't matter how you get it as long as you find the answer. This can be solved in like a single something like this, I don't know. It'll give the answer, but it's so risky. So just write as many lines as you need for this. We're gonna do several lines to this, okay? So only 6 can be selected. So 1, 2, 3, 4, 5, 6 for visual representation. Now, let's just pretend that there is, in this group, there is one Anwar. So that means there cannot be a bow in here. But these remaining 5 slots in the 6 members, it can be any of the remaining 18 members, right? So this slot here, they can be any of the 18. This one, any of the 17, 16, 15, and 14. Alright? And then we're going to do a second line here. So 1, 2, 3, 4, 5, 6. This time, bow is going to be here. So it's going to be one option here. And the remaining can be anyone else except Anwar. So there's 18 possible choices. So this is going to be exactly the same. 16, 15, 14. And then, is that it? No, there's actually one more line. What if both of them are not in? It says at least. Oh no, it says at most only one of them. So that means them both not being in the community is completely possible. So we can do 18, because there's 20 total, but we're not going to count unwindable. 17, 16, 15, 14, 13. And now just times everything together, and it should give you the answer. I'm going to calculate this. We'll give 1, 5, 4, 2, 2, 4, 0, 0. Moving on, man, this is a speed run. The gate for the garden has a lock with 6 character passcodes. The passcode is made from 1 through 6 letters and 9 numbers. Yeah, characters cannot be used more than once. Oh, okay, can't repeat. The number of possible passcodes that have 4 letters followed by 2 numbers. Okay, so that means this lock here has 6 digits made from these numbers, and the numbers and letters can't repeat. Find the number of possible passcodes. There are 4 letters, so that means the first 4 have to be letters and the last 2 have to be numbers. Wait, this is so simple. What? How is this and this 2 marks? The first 4 can be any letter, right? So the first one can be 6, 5, 4, 3, right? Can be any of them, and then the last 2 numbers. So you got 1, 2, 3, 4, 5, 6. Oh, this is 9. So it's just 9 times 8. Yeah, what? Just calculate this. This is the answer. Okay, never mind. Moving on. Given that n is greater than 4, show that this is this. Okay. Now this is a fun one. So this, we need to convert it into a calculatable form. A very fancy word. If you go all the way to the top here, and on the sheet it gives you all the answers for some reason. This right here actually means NCR, which is what we see. This actually can be written in this form here. Let's go back to that question. So n minus 3 multiplied by NC3 is actually n addition over n minus 3 permutation 3 permutation, that equals 4 times n permutation over n minus 4, or r, whatever down there, permutation 4 permutation. So this exclamation mark, we need to get rid of that. Alright, that thing, disgusting. We don't want that there. So this can actually be written as n minus 1, n minus 2, n minus 3. There we go, we stop there. We just keep going down till we reach the bottom number. Why does this work? I have no idea. We just accept it and take the marks. So this equals, oh, I forgot minus 3 here equals to 4 times n, then n minus 1. Where do you think I'll stop? N minus 2? Should I stop here? Huh? No, n minus 3? What about here? That's where I stopped, right? No, we go n minus 4. Because that's the bottom value there. I think n minus 4. Stop here. And from here, we start crossing out. Let's look at the first part here. This, we can cross out with this. This one, n minus 4, we can cross out with this. However, we can actually cross more things here. Like this can be crossed with this. Wow, cross-sided, that's crazy. We can cross this with this. You can cross this with this. And now what you're left with is n over, let's convert this 3 permutation. If we do it on a calculator, it actually is 6 over 4n over, and then for permutation, if we do it on a calculator, it's 24. And then like this, easy lah, you know, 24n equals to 24n. Okay, yeah, we shouldn't, okay, yeah, we don't have to solve that, it just says we just need to show the equal. So yeah, 24n is 24n, they're both 24n. So yeah, we've solved it, we can move on. It's like, given that nc3 is 5n, I don't care what that means, show that this is this, okay. So whenever you see this, if we go all the way to the top, to the cheat sheet, the paper that gives all the formula for some reason, I don't know why they do that, you can see that, where is it, ah, there it is, NCR actually equals this, like this is NCR. So using this, I actually already did it out there, but I just want to show you again. And permutation, we can rewrite this as n minus 3, permutation 3, permutation equals 5n. Now we're going to do the same thing where we want to remove this question mark. So n permutation can actually count down as you saw earlier. So I just want to keep going. I'm going to go until negative 3 because that's what we want, right? So you can cancel them out. If the number is smaller or bigger, then you either go further or less. n minus 3, permutation 3, permutation, so this equals 5n. Now you cancel the tops, right? So now we have n minus 1, n minus 2 over 3 permutation, this equals to 5n. So 3 permutation, this equals to 6 actually. We can bring it over so that n minus 1, n minus 2 equals 6 times 5, that's 30n. So before I expand this, you see both sides have an n, so I can cancel that out. Now I'm going to expand this, so this is n squared minus 3n plus 2. Then now I bring this 30 over, so minus 30. So this will give n squared minus 3n minus 28. This equals 0. Is that correct? N squared minus 3n minus 28 equals 0. Yes, it's correct. So now solve n. Remember the song? Negative b plus or minus the square root of b squared. You know this quadratic formula. It's so easy to solve it. The diagram shows the curve this, and the curve meets the y-axis at this point. The tangent to the curve at A, also it's, what? Tangent to the curve at A is what we kind of, oh, the tangent of the curve, so they don't tell you, but we kind of got to find it right now. A tangent is a line that touches this point. Did you know tangent came from the word tangible, which means can't be touched, which is kind of stupid because you can touch anything on the line. Anyway, the diagram shows this, okay. So it meets at A. So this means that the x is 0. So y equals 5. I want to find that point first. 5e 2 to the power of 0 minus 3. So this should give, let me just check my calculator real quick. 0 minus 3. This is 2. This gives 2. So that means that this point here is 0, 2. 0, 2. I thought of something, never mind. Okay, so now we have a point. I want to find the length of A to B. So this point where it crosses the x-axis is point B, right? So to do this, oh man, it's differentiation. It's my favorite, okay. So whenever a tangent of a curve, you can find the gradient of the tangent by differentiating the equation of the curve. I hope that's not complicated. So if you dy dx, this equation here, so 5e 2x minus 3, you can get and you solve it, you solve it, you will get the gradient of the tangent. So this is a point where x is at 0, it's an x 0. Let's keep that in mind first. Now when we dy dx this, for e, exponential is kinda weird, alright? You just only pull the coefficient down, so 2 times 5 is 10. However, nothing changes, it should stay 2x, and then when you dy dx a whole number that has no x, it disappears. So this is it. Now we just have to solve this where x is 0, so we put the 0 in there, pull the calculator out, e to 0, this gives 10. So that means the gradient of this tangent, wow, that's a steep line. So y equals 10x plus c. So we know one point is 0, 2. So we need to find c. We can find c using this. So 2 equals 10, 0 plus c. So that means c obviously is positive 2. So now we have the equation of the tangent, y equals 10x plus 2. We can fill this in to find point b because you want to know how long AB is. So b, we don't know what the x value is, but we know the y is 0. So that means 0 equals 10x plus 2. So that means negative 2 is 10x, and negative 2 over 10 is x, or negative 1 over 5 is x. Now, we have 2 points, right? We have 0, 0, 2, and we have negative 1 over 5, 0. These are the 2 points, and using this, we just need to do the classic formula to find distance. Okay, this does not look like negative 1 over 5, that's because I kind of roughly sketched it. But we take x1, this x, plus, no, minus this x, so minus negative 1 over 5. We square this, plus the first y, minus the second y. You square this, and this would give you the answer. This is the length. I'm not going to calculate it, I'm way too lazy. Alright, moving on. Variables x and y are such that y is related to x by, oh my god, what is that? Okay, use differentiation, which is dy dx, to find the approximate change in y as x increases from this to this plus h. So we don't know what it is, but we don't need to know what it is. So this is pretty complicated, but I'm going to do something called the ultraviolet method. So this is u, this is v, these are all the fancy shortcuts that I learned from studying Addmaths for only 3 months. So let's dy dx this. To do it for fractions, we're going to do dy dx the top, so dy dx for x3 plus 2 sine 8x multiplied by just 1 minus x. I did different, let's ignore that. Then minus the dy dx, holy shit, 1 minus x. Then this separately, just times the regular number. I can't fit that, there's an x over there. Okay, and then this whole thing, you gotta put it over 1 minus x squared. Oh my god. Okay, let's start with this side, dy dx. Okay, 4x3, that's 12x2. Alright, we know how to do this. And now for this one, 2 sine 8x. You have to, okay, sine, when you dy dx, sine, it gives cos. So this is 2 cos 8x. But then you have to multiply it with the dy dx of whatever numbers in there, so that makes 8. Wow, that is complicated. And then let's dy dx the second part. So 1 minus x it's just -1, right? -1, then you multiply it with the regular number here. And the whole thing over, well, I'm not going to expand it yet because I'm scared that I might have to do some cancelling later. So we'll find out when that happens. So usually I'd simplify this, but you know, I'm kind of lazy, got time limit and all that. Excuses. I just want to find what y is, the approximate change in y, so I couldn't really care. So we know that x starts at 0.1 before it increases with h. So we're going to fill 0.1 into this thing here. Let me just check. Alright, so this would give 16.15 over 1 minus 0.1 squared. This gives, oh wow, 0.81, that's a very small number. So this is the number, this is the dy dx. And all we gotta do now, it's very simple, you times it with h. I think you need this in decimal point or whatever, this is the answer, boom, 6 marks just like that. Oh, it's too easy. The functions f and y given, so f is this, oh it's a terrible function, and g is this. All x are real, and then find the range of f. Oh yeah, that's simple, it's this thing, yeah, okay, moving on, write that there. Solve the equation where the inverse of f is this. The inverse of f means the dy dx of sec x. So if you remember trigonometry, you remember sin, tan, and cos. Well, welcome to cosine, cotangent, and cot, and sec. Yeah, this shit's crazy, man. So sec is actually, the inverse should be 1 plus sec x. Yes. So it's saying that this equals to 2 pi over 3, if I'm not mistaken. So if 1 plus this is this, that means sec x, we don't know what that is yet, should be 1, no, it should be 2 pi over 3 minus 1. So usually on a calculator, you can solve this by just, you know, arc tan or arc sin, but obviously this is sec, but sec is actually 1 over cos x, right? So that means we just have to do 1 over inverse of this to get x. So that means 1 over inverse cos 2 pi over 3 minus 1, which should give you the answer here. My calculator's lagging, that's crazy. GF exists, huh, really? Damn, that's crazy, man. I don't believe it. Find the domain of GF. So domain is the range of the x values. So you put f into the g first. So that means 3. Instead of x, we're gonna put sec square x, because they want to put the f into the g. Then minus 1. So 3 x squared minus 1. Find the domain of 3. Oh yeah, g should just be greater than 3. Alright, why am I bothering with that? Solve the equation where this equals to 1. Oh man. So 3 sec square x minus 1 equals 1. Alright, what? 5 marks? How is this 5 marks? So easy, what? What? I'm being scammed. This is 1 over 3. We bring it over. It's so, what? So simple. What? 1 over 3 plus 1. So sec square is actually 1 over cos square x. So like this. So that means 1 over this is equal to cos square x. So 1 over 3 is 3 over 4. Yeah, so cos square x equals 3 over 4. So we're going to bring the square over, so that means cos x equals the square root of 3 over 4. And then x is just the arc cos of this, so give me a second. Arc cos of the square root 3 over 4 is 30. X is 30. Just like that. Damn, damn. Okay. The function h is defined by hx equals ln 4 minus x. For x is smaller than 4. Sketch the graph of this and sketch the graph of this. Oh my god, it's so easy. ln is something you can press on your calculator, so you can just put ln 4 and whatever x value you get, it'll start putting up points. You just gotta sketch the graph out like this, and then you just gotta find the point that's intersect. It's basic maths. What? So why do they tell you this? For the y value, just put x is 0 in here and just see what you get. And for this, for the x value here, just make this equal to y, and then like slowly. Oh, I should teach you this. Let's say ln 4 minus x equals to 0, right? If you bring the ln over, ln becomes e. So e0 equals 4 minus x. Yeah, then you just solve this. Yeah, it's so simple. Then to do the inverse, alright, to do inverse, let's just find the inverse for you. ln 4 minus x equals y, like this, alright? We want to isolate that, so let's bring ln over first. So 4 minus x equals e to the power of y. So if 4 minus x is this, that means 4 minus e to the power of y equals x. Yeah, this is the inverse. Just make this x. And then you just gotta put x values in, you draw the one out like this. Yeah, and then you just state the points here. Yeah, it's so easy. What? Okay, there. Put that for you. Show that this equals this. Wow, they give you the answer. How convenient. Alright. So the dy dx of this. Alright. Oh, let's just convert this real quick. So x plus 4 over, we can't dy dx this, you can't change it. So x is actually 1 over 3 like this. And then now we can do the UV method. Wait, you can actually just fill this in your calculator. You can literally put this whole thing in your calculator. Oh my god, just Google it. You can put this in your calculator, it'll show this. What's the point? The diagram shows part of the line 10y equals 7 minus 3x. The part of the curve, this one right here, this, the line of the curve intersects the point at A. Okay, verify that the y coordinate of A is 0.1, so show that this is something 0.1. Calculate the area of the shaded region. Okay, so here's a fun fact, alright? This, I know it looks like a complicated question, but usually questions like this, it's actually really easy, just really long, but long and easy, alright? So whenever anything crosses paths, like what you see here, doesn't matter, sometimes the curve can look like this, and then like there's a line touching on that. If they touch at all, alright, you can solve this with simultaneous equation. So let's prepare it for that. So if 10y equals 7 minus 3x, that means that y equals 7 minus 3x over 10. And then now we can do simultaneous, right? 7 minus 3x over 10. This equals to 1 over 3x plus 4, like this. Alright, we're gonna do cross multiplications. 10 times this equals 7 times 3x, that's 21x. 7 times 4, that is 28 plus 28, yeah. And then negative 3x and negative 3, that's negative 9x squared, remember. Then 4 is minus 12x. Yeah, if you put this all together, it should be this. Yeah, it's pretty simple. Let's just move on from that. Now we just need to calculate the area of the shaded region. That's the important question. I don't know what's the point of this one. It's like, I don't know, to warm you up or something. Alright, yeah, you know what? I'm gonna end it right there. I hope you learned a lot of tips, because, you know, a lot of people told me just practice hard. See, those are the words that come from people who have never done Addmaths. It's not about practicing hard, it's about getting good. Alright, goodbye.